Hey guys, this is the start of Unit 2. We're going to talk a little bit about writing equations by looking at tables. Okay, we're just going to fly through this. Shouldn't be too bad at all. It's going to kind of continue off of patterns from last unit. Okay, so it says patterns show up everywhere in math. One way to display a pattern is through a table. Okay, so we have a little table down here, and we want to see what kind of patterns do we notice. Okay, let's write a next and now equation for it. Okay, so we know that every time to get to our next step, we're going to multiply each one of our numbers on the left, or to get to your next term, 1, 2, 3, and 4 are your terms, to multiply those by 3 to get your output. Okay, so for instance, to multiply by 3 here, you get your output. Multiply by 3, get your output. So you would have next equals now times 3. Okay, so a pretty easy one to notice. Really not too bad. Okay, let's look at the next example. We're going to look at how to write an equation for the width of a rectangle if it's 4 inches greater than its length. How can we show the changes in width as the length changes? Okay, what I want you to remember, always, and write this down, is that a table, sorry for my handwriting, a table can show a pattern of repeated action. Okay, a table can show a pattern of repeated action. Again, I apologize for my handwriting. Okay, so before we get started, we're going to set up two variables. It talks about width and length in the problem, so we're going to let L equal our length and W equal width. Okay, so let's go ahead and fill out our little table. We're going to have one side be length and the other side be width. Okay, and the problem originally said the width of a rectangle is 4 inches greater than its length. Okay, so if our length is 1, for instance, our width would be 4 inches greater, and of course it would be 5. Okay, let's go ahead and fill out the rest. If your length was 2, your width would be 6. If your length was 3, your width would be 7, and 4 would be 8. So let's look at the first question. It says, what happens every time the length changes? Well, if you set up an equation, what you're trying to find is width. Okay, so to find your width, you have to have your length, whatever number that may be, and you have to add 4 to it. Okay, so your width is always your length plus 4. If we wanted to write an equation to match this table, you can just put the same thing as up here. Okay? Same thing as up here. That will give you the solution to the equation that would match that table. Okay, go ahead and flip over to the next page. Okay, we're going to go over a couple of different examples. Okay, the first one, Kristen got a $20 iTunes gift card for her birthday, and each song costs 99 cents. We want to figure out how much is left on her card every time she downloads a song. Okay, remember, right here, you need to write, a table can show a pattern of repeated action. I want you to remember this. A table can show a pattern of repeated action. Okay, so we're going to let T equal what's left on the gift card. Okay, so T is going to be what's left on the gift card after each music purchase. And D is going to equal number of downloads. Wow, can't even spell. Okay, number of downloads. Okay, so let's go ahead and set up our table. Okay, D for downloads and T for total of what's left. Okay, so if we have one download, it costs 99 cents. And of course, you'll have 1901 left. Okay, and then if you fill out the rest of your table, for instance, if you had 2 downloads, you'd have 1802 left. If you had 4 downloads, you would have $16.04 on your gift card. And if you had 9 downloads, for instance, you would have $11.09 remaining. Okay, so let's set up an equation for every time that she buys a song. Okay, so we're going to set it all equal to T, or what's left on her gift card. So T represents what's left on her gift card. Then you set that equal to the original balance. She had $20 on her iTunes card. And then every single time you take away 99 cents. Okay, so what happens every time to find the total, you have to take the amount that you had and you subtract 99 cents. Now, if you wanted to set up an equation, all you would have to do is tack on a variable on your price there at the end. Okay? So every time you have a download, you'd plug in whatever amount of downloads you had at the end, and that would give you the amount you have left on your gift card. Okay, let's take a look at a measure. Okay, sometimes they're going to give you a table that doesn't give you a scenario. They're just going to give you some numbers, and you're going to have to figure out what comes next at the end of the table. Okay, so your input, the first one is 3, and your output is 6. Okay, that's a difference of adding 3. You also add 3 in all these other ones. Okay, so you know that your next and now equation is going to be next equals now. And then to get to your next one, you always have to add 3 each time. Okay, so that's a very straightforward one. So for instance, if you went to the 8th input, you would have to add 3 to that, and you would get 11 for your output. Okay, pretty straightforward. Last page. Okay, let's take another look at another problem like this. This time they're going to make it a little bit more challenging on you to find the output. Okay, so if your input is 2, you have to get to 5, you have to multiply it by itself times 2 and then add 1. Okay, so times 2, add 1, and that gives you 5. Same thing with 3. If you multiply 3 times 2, that gives you 6. Add 1, that gives you 7. So your equation would be next equals now times 2 plus 1, and that would always give you your next output. So for example, if you had a 7th input, you would multiply that by 2, which is 14, and add 1, and your next output would be 15. Okay, I would like you guys to try number 1 and you try number 2 all by yourself. I think you guys can do it, so just take a few seconds and figure out what those would be. Okay, make sure after you're done to complete your Whisk and your Google form. Peace.